Classes and inheritance are an important topic in Python, so let's sum up. All types in Python have a class. Classes define the structure and behavior of an object. The class is determined when an object is created and is fixed for the lifetime of the object in the general case. Classes are the key support for object-oriented programming in Python. Classes are defined using the class keyword followed by the class name, which is in camel case. Instances of a class are created by calling the class as if it were a function. Instance methods are functions defined inside the class, which should accept an object instance called self as the first parameter. Methods are called using the instance.method syntax, which is syntactic sugar for passing the instance as the formal self argument to the method. An optional special initializer method called double_init can be provided, which is used to configure the self object at creation time. If present, the constructor calls the double_init method. Double_init is not the constructor. The object has been constructed by the time the initializer is called. Arguments passed to the constructor are forwarded to the initializer. Instance attributes are brought into existence simply by assigning to them. Attributes and methods which are implementation details are, by convention, prefixed with an underscore. There are no public, protected, or private access modifiers in Python. Access to implementation details from outside the class can be very useful during development, testing, and debugging. Class invariants should be established in the initializer. If the invariants can't be established, raise exceptions to signal failure. Methods can have docstrings, just like regular functions. Classes can have docstrings. Even within an object method, calls must be preceded with self. You can have as many classes and functions in a module as you wish. Related classes and global functions are generally grouped together this way. Polymorphism in Python is achieved through duck typing, where attributes and methods are only resolved at point of use. This is called late binding. Polymorphism in Python does not require shared base classes or named interfaces. Class inheritance in Python is primarily useful for sharing implementation rather than being necessary for polymorphism. All methods are inherited, including special methods like the initializer. Along the way, we found that strings support slicing because they implement the sequence protocol. Following the law of Demeter can reduce coupling. We can nest comprehensions. It can sometimes be useful to discard the current item in a comprehension using a dummy reference, conventionally the underscore character. When dealing with one-based collections, it's often easier just to waste one list entry. Don't feel compelled to use classes when a simple function will suffice. Functions are also objects. Complex comprehensions or generator expressions can be split over multiple lines to aid readability. Statements can be split over multiple lines using the / line continuation character. Use this feature sparingly and only when it improves readability. Object-oriented design, where one object tells another information, can be more loosely coupled than those where one object queries another. Ask, don't tell. Thanks for watching, and we'll see you in the next module.